Good. How are you? Doo-doo. 19th, T minus 6 days. Six. Hey, yes. 12, 19. Evaluating. Oh, yeah. So yesterday you guys learned how to tell if something is a function. I realize that not all of you are done with that assignment, and that's okay. You can keep chipping away at it. I'll put the due dates for all of these out. I thought originally that the end of the semester was going to be tomorrow or Thursday, and I was wrong. Like it doesn't end until I think 2 weeks after we come back from Christmas. So I'll bump all the due dates on the deltas out so they don't turn red because I want you still to be able to finish them. So anyways, just get that done. But then the new stuff today is this. So yesterday you learned how to look at something and tell, is it a function? Today, this assignment, these notes, that's not going to be our concern. Today, everything is a function. Okay. So we're going to look at functions from a different angle and not say, oh, is that a function? But rather say, here's a function. Now I'm going to have you do some math with the function. So first things first, you have to get introduced to this notation. And I just want to get this out of the way so that we don't read this incorrectly. You would normally look at that prior to today and think that that means like f times x. That's what a normal person would think. This actually, when you use words to say this, so I don't want us to communicate poorly, you say f of x. So get used to this notation. It's going to become a kind of a part of what you do. So when you see f parentheses x like that, it's f of x. And what it means is it's going to be confusing for like a minute or two, is that the function's name is f and it plays with x's. So a function is like a machine, and what it does is it waits for you to give it a math, like a number, and then it churns it around and it does math, and then it spits you out an answer. That's how functions behave. They're like little math machines. So it has like an input, and you throw a number in there, and it's like beep, boop, 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 boop. It calculates an answer, and then it spits the answer out to you. So just like yesterday, the x is going to be the input, the number we feed in, and then the f of x or the y value is going to be the number that it spits out. You'll see. It's actually today's work is super easy once we get over the hurdle of the new language and how odd it looks. So again, when you see that notation, you don't read it as like f parentheses x. You literally will always say, all the way through college or as many levels of math as you take, f of x. And f can change, by the way. You'll see some functions today named g of x, h of x, j of x. So the name of the function is the letter in front, and the letter, the input that it wants to play with is the letter in parentheses. So again, this one up here would be a function named f, and it takes x's as its food. You feed it, and then it spits you out waste product, which maybe I shouldn't say it like that. It's not a waste, but it's kind of like it pooping it out. Got it? All right, so let's take a look. Let's say I had a function like this. And once you see this with clarity, then explanation done. We move on with the easy part. What's the name of this function? F. His name is F. Okay, so the function's name is F. What does he desire to eat? X's, right? So he's a function named F, and he eats X's and then turns them around in the innards and then spits out an answer. Now, this function, the machine, the inner workings of this machine behave predictably based off of this over here. And this, I want you to put in your notes, that part, the mathy part that's after the equals sign, has a name. It's called the function rule. And all functions have a function rule. The function rule is what determines what's going on inside of the machine. So this particular machine, his name is F. He's going to sit around and wait for you to feed him X's. And when you give him an X value, a number, he's going to do some math with your number, and then he's going to spit the answer back out. That's how functions behave, literally like a little machine. What math specifically will this particular function f do with our input? What will he do to the number I give him? It's based on the function rule. What will he do? What does the function rule say he'll do? What does this part of the function rule imply? What does 5x mean? It means he's going to multiply my input by 5. So whatever I give him, he's going to take it and multiply it by 5 and have an answer. But then what's he going to do with that answer? He's going to take away 4, right? He's going to do -4. He's going to subtract 4, and then he's going to give me an output. So the question is like, well, what do you want me to put into the machine? Well, that's going to be given to you like this. So there's going to be a function like this, defined, the name, the input, the function rule, and then there's going to be usually like a comma, and someone's going to say, okay, find f of -3. So now we know the number that we're feeding into the machine is going to be -3. So whenever you see f of a number, that number is something that you're to put into the function and let it do its thing, and then it'll spit you out an answer. And the math is generally relatively easy. There'll be some that are a little bit more missable, but this one's pretty simple. So if I wanted to find f of -3, which I do, what that's going to look like is this. 5x minus 4. All I did was take the thing I underlined in green and I copied it down. That's the function rule. But you'll notice where the input sat. The x is where we change him into our input. I put an empty space there. And that's where I feed the input. And what is our input for f of -3? It's right there. So you just change x into -3 and do the math. I would assume at this level, this point in your life, the math in a case like this would not be a struggle. What is 5 times -3? And then what is -15 minus 4? So we make the following statement. We say, okay, everybody, f of -3 equals -19. Simply put, that means that this particular machine, based on his rule, if I feed him a -3, he'll spit me back out the answer of -19. The input is the -3, the output is the -19. Got it? Okay, let's try another one. What's this function's name? G. Very good. Just G is his name. What is he a function of? X. That means he's a function. He waves at you and says, hi, my name's G. I play with X's. So his name is G. He takes inputs of X. And what does he do with inputs once you give them to him? What does he do? What's his math? What does his function rule right here claim he will do? He'll multiply whatever I give him by what? -3, right there. That's what that first part says, is he says, I'll take whatever you give me and multiply it by -3. I'll get an answer. And then what will I do with my answer? I'll add 4. So the math is, you give it a number, it beep, boop, 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 calculates the answer and spits it out. So if I put -3 in place of X, this would now say -3 empty space plus 4. I change the input location to an empty space. That's where I wait now and say, what will I plug in? What will I put into the input? 5. Very good. All I'm doing is changing X into what someone tells me to. And then I let the machine do its thing. What is -3 times 5? -15 plus 4? -11. So we make the following claim. We say, okay, world, I got you. G of 5 equals -11. This statement is our answer. That's our statement of saying, I did it. I fed the function of 5. It gave me back a -11. So far, so good? Okay, let's do another one. This function What you have to really understand and focus on, if you're easily confused, is that this part, I'll underline it and now for the third time, is the function rule. That's the meat and potatoes of the problem. That's where the rubber meets the road, so to speak. Like everything that's going to happen is going to happen based off of that rule. The most common missed wrong answer to this would be someone would just look at it and go, oh, this is easy. It's negative 20. It's not. Let's take a look at what's going to happen. So when we copy down the function rule, it's going to say negative blank space minus 10. And what's going to go into that blank space? What's going to go into that blank space? Very good. So remember, the input is right here. I'll circle it in yellow. And that input always goes where X used to be. And if I put a negative 10 in there, then I see, oh, yeah, it's not negative 20. What right here is the negative of negative 10? Positive 10. And what is 10 minus 10? So we make the claim that, okay, h of negative 10 equals 0. Say, like, what's the answer? The answer is 0. But this is our statement. It's kind of like at the end of an equation, like we did at the beginning of the year, how we would always say x equals 4, y equals 2/3, stuff like that. We say h of negative 10 equals 10. Got it? So that's 1/4 of what we're doing today. But the worst of it is over because now you understand the lingo, the language. You understand what those parentheses mean, that they are a special notation, and we use a special few words to speak them. Right, so now we're going to up the difficulty a little bit. These, by the way, were all called linear functions. They just have x to the first power. Now you're going to see some quadratic functions. And even though we don't do a full unit on quadratic equations until like April or March, we can still work with quadratics in this sense. This is easy. So let's go f of x. And here's his rule. What's my function's name? What's my function's name? F. Good. He's like, hey, everyone, my name's F. What does F like to eat? X's. He says, I'm just going to sit around and wait. Whatever your X value is, feel free to feed it in and I'll do my thing and I'll spit you back out what you need. So his name is F. He takes inputs of X's, churns them around and spits out answers. The answers are kind of like Y values for the record. Okay. They're like kind of one and the same. So if I were to go now and calculate f of -3, which is what I'm being asked to do, I'm going to rewrite the function rule, and I'm simply going to leave a blank every time I see an input space, an x. So I'm going to write input squared minus 4 times input minus 12. If that's confusing, just take another look. All I've simply done is replaced this x and this x with these empty spaces that await what they want, their inputs. What are we going to put in those blank spaces? -3 goes there, and -3 goes there. And again, we hope that the math is simple enough, but we know that sometimes that's not always the case. So let's talk in pieces about this. First, the purple bubble. What is -3 when you square it? First off, it's a positive, right? And that's going to help you when we get to the quadratic formula. When you square something, it's always positive. Even if you use a calculator and if you type it in wrong, that's your problem. Like anytime you square a negative, and I mean 100% of the time, it's going to turn positive. So this portion right here, the purple bubble, becomes 9, right? Okay, and now we move on to the second section. Now let's talk about this green bubble. That's a -4. I know it says minus, but it's like a negative. You know, they're kind of the same thing. What's a -4 times a -3? So I'm going to put plus 12. And then I'm going to copy down, of course, at the end, the minus 12. All right, what's 9 plus 12? What's 9 plus 12? And what's 21 minus 12? 9, right? Another way to have done this problem would be through, I think it's what Kaysen was doing over there. Sergeant Sleepy was saying, if I had a plus 12 and a minus 12, then of course those are going to cancel, right? So you could bypass a lot of the work in a problem like this and just know that your answer is going to be 9. So again, we make the statement to the world that, okay, everybody, here it is. Here's my statement. F of -3 equals 9. Inputs and outputs. Okay, I'm now going to show you a couple problems that are the ones that get missed the most. All right, so you've been warned. And I know that we kind of tend to think like, I'm not going to do that. It happens a lot. So let's do another function. We'll call him J. Okay, he's a function of X. What's his name? J. What's he eat? X is good. So J is a little machine sitting there waiting for you to feed him some X values so he can do his thing and serve his purpose on this planet. So we are going to find J of -4. I mean, you can miss these, yeah, but if you show work, you probably won't. I can tell you that this problems like this and the next one get missed a lot just because of the negative in front. And sometimes people boof the order of operations, which is, kind of sucks. So here it goes. I'm going to rewrite the function rule. And when I do, every time I get to an X, I'm going to put a little pair of parentheses as if to say, insert number here. So I'm going to put -2 blank squared plus 5 blank minus 11. Again, just replacing X's with awkward blanks. Everybody okay with that? What's going to go in those two blanks? -4. Now, I realize I'm getting close to the 20-minute mark, which scientists say is when people stop listening. So don't stop yet. I need a few more minutes. A very, 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 very common mistake at this point in time is for people to get ahead of themselves and do -2 times -4. Don't do that. That is just like flipping the middle finger at the order of operations and saying, you mean nothing to me. The order of operations exists for a reason. It's like our book of rules, right? It tells us that we know that exponents go before multiplication, correct? So what I need to do is not fall for this. I'm not going to do that multiplication. It's so tempting and right there. But what am I going to do first? I'm going to square -4 first, right? Sometimes you got to do math in a different order. Like it doesn't read like a book. It's not like that. So what this is going to say now is -2, he had to wait his turn, times what? Very good. Plus 5 times -4 minus 11. And then the rest from here, we're just going to like grind our way from left to right and knock these answers out. At the beginning, what's -2 times 16? -32. And in the second portion, the second third of this, what is 5 times -4? So I'm just going to put a -20. And then from here, I just better pray I know my basics. I better pray I know my number line. What's -32 minus 20 more? -52. So like we're going way down deep in the hole here. So we're at -52 already, and we have to go down 11 more. Where are we at? So we say that J of -4 is equal to -63. The machine says, hey, if you feed me a -4, I'll give you back a -63. Still good? Right? And then finally, the most missed type of problem, and then we'll get to the super easy graphing ones, is something like this. What's this function's name? H. What does he gobble up and eat and digest? X's, right? Later on, when we start talking about like contextually specific functions, like if you had a profit function that was a function of sales, Your function might be called like P of S, where the profit is a function of number of sales. So just be advised that you must understand that language, and that again, the letter over here is the name of the function. The letter in here is what it takes as inputs, okay? Ours are all going to be X's here for a little while. F of X, H of X, G of X, stuff like that. Find H of -2, right? So here we go. I'm going to copy down the, what's it called again? What's this thing called? The function rule. And I'm going to be patient about this because I don't want to miss it. I don't like missing problems. I do sometimes, but I don't like it. So I'm going to write negative awkward space squared minus 11 times awkward space plus 8. I'm only going slow because I've just sat on this side of the desk for 28 years and I know what is going to happen if you're not careful. So here it goes. What am I going to put into those awkward spaces? -2. Now, again, I do this because I care about you and your success, and I just want to get in the way of potential errors. You can only imagine how tempting this is for normal people, right? What's a negative and a negative? You don't get to do that because the order of operations says it slaps your hand. It says no, 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 no. A negative and a negative, that's multiplication. You don't get to do that. You don't get to rush in and do that. You must do this red thing first. Follow? That negative out front is away his turn. So if I do the red jelly bean thing and I square it up, what do I get? I do not get -4. I get +4. But then that negative that had to wait his turn is like, oop. And people sometimes go, wait, I thought when you square something, you get a positive. I did. But the negative out front was like, wait, I'm going to come in and do my thing no matter what. And while we're here, we might as well multiply out this green thing. What is -11 times -2? So we're going to put +22 plus 8. And then again, we hope and pray at this point in your life that this is not an issue. What's -4 plus 22? +18. And what is 18 plus 8 more? 26. So we then make our statement that H of -2 equals 26. Any questions about that so far? Okay. The other half of this will, I think, unless I'm jinxed it, it should go fast. So the only way for me to teach you this really practically is to show you what it looks like on Delta Math. So now we're going to evaluate functions without having to do any math. We're just going to look at graphs. So don't get your Chromebooks out or stop listening or anything or think that this is over, because then you're going to be the person asking questions about what I'm about to explain. So hang with me, give me a few more minutes. So you're going to have a couple different sections of problems. One of them is going to look like this. And I know this looks totally weird. That's okay. You got this. So here's what it means. First off, what's the name of our function? F, right? And he will take X values, okay? So the function is Y equals F of X, and he says, okay, whatever you feed me, normally I will just do math and spit you an answer, but we don't have a function rule. We just have a graph. So the input is your X-axis. So all I'm simply going to do is go to -7 on my input axis, which is right here. And then I'm going to go find the graph. Is the graph above me or below me? Above me. So the F of X is really just the Y value. If you go to my little red circle, which is at the input of -7 and go up, 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 how far up do you have to go until you intersect with the graph? So the answer, and I mean simply put, is 9. You type in the Y value that's associated with the given input value, and that's that. Let's do another one, okay? How about this one? My function's name is F, and he says, I want to know my Y value when I'm at -5 on the sideways. So go left to -5. Is the graph above you or below you? How far? So what's the answer? So I just type in -2, submit, done. Let's do another one. Here's a function, his name is F, and he says, find my output when my input is -3. So everybody with your eyeballs, go left to -3 and then find the graph. It's just operation find the graph. Where is it? Below us at -6. Yep, and you'll do better probably when you can see it on your own screen, but it's right there at -6. So I'm just going to type in the output value. Remember, the Y value and the output value are the same. And then finally, the last piece of this, these are called piecewise functions. Hope you haven't fallen asleep because we're not done. These look weird, right? You'll see more of these probably in Algebra 2. We don't talk a lot about piecewise functions in Algebra 1, but it's just a function that got broken into pieces. And so if I said I wanted to find f of -1, I simply go to -1. Do y'all see where -1 is at right here? And now look above you. Do you see the graph? So go right here to -1. Look above you. Do you see the graph?
No.
I don't. Look straight up. I'm sorry, I don't see any graph up there at all. So then I'm like, well, it must be below me, right? So then I look down from -1 and I go down, 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 down. And do you see the graph below you? I don't either. What that simply means is that this function is not defined at -1. So I'm going to go down here and I'm simply going to click undefined and hit submit. Sometimes there is no graph point above you or below you, and that's okay. Let's do another piecewise. Do you see these two dots right here? This goes back to yesterday's lesson as to the vertical line test. Why does one of those have to be hollow, meaning I don't count, and one has to be solid, meaning I do? Well, it wouldn't be a function if one of them, if they were both colored in, would it? The essence of a function, remember, is the vertical line test. The vertical line test says you'll see no points that are above and below each other, which is why this graph has a hole and then a solid directly above it. And the reason for that is if I said to you, find f of 1, everybody right now go write 1 and look up. If you ever have two choices to choose from, it's not a function, right? So that's why if I did say, and I don't know what this problem says, I haven't scrolled down yet, but if it did say f of 1, which it might, I don't know, which one will we pick? The 5, right? Don't pick the 3 because the 3 is the one that says, I'm not in this. You see the hollow circle, I'm not in this. Pick the one that's colored in. So I would pick the 5. And it does say f of 1. So at f of 1, make sure you don't fall for the hollow circle, pick the solid circle, and choose 5. Okay, let's do another one. Neat, huh? Let's find f of 1 this time. Go to 1. Look up. Do you see the graph? I don't either. Look down. Do you see the graph?
Yeah.
No, you don't. What's below you at 1?
Oh.
It's a hollow circle. So what is the f of 1? It is undefined. Yeah, there's a circle there, but that circle being hollow specifically says, I don't count, right? Let's do another one. Okay, we're going to find f of 0. Everybody, 0 is right here where I'm moving my mouse pointer. Look up. Do you see the graph?
No.
Look down. Do you see the graph? What is it? All right, let's do another one. F of -5. Go to -5. Look up. Good. You didn't fall for it this time. There's an open circle up there, but it doesn't count. Look down. No graph. Another one. Undefined. Got a lot of undefineds in a row. That's, I don't think, going to happen too often, but let's go to f of, oh, well, here's another one. Jeez Louise. I say that and then, there we go. F of -3. Everybody go left to -3. Look up. Do you see the graph?
No.
Nope. Look down. Do you see the graph? I do. Do you see that solid circle directly down below -3? He says, I'm in. I count because I'm colored in. So what's his Y value at -3? -2. Good job. You guys feel like you got this? So your assignment is going to be a collected mixture of the mathy ones like we started the lesson with and graphy ones like this. Luck of the draw, I assigned them all equal importance, so you'll have an equal chance of getting any of the 4 flavors. And that is that. If you don't use paper for the quadratic ones and you miss them, I'm not going to have any sympathy for you at all. So I would model how you do it after what we did in our notes. Copy the function rule, be deliberate, be careful. You got this.